Hi everyone. As Kenny already mentioned, we're going to talk a bit about aggregates. My name is Gien Verschatse. Don't worry about pronouncing it. Nobody knows how to do it but me. I was a software developer for about 10 years, and then I became a consultant. And I noticed that aggregates was also a bit tricky. So I wanted to do a talk together with my colleague Thomas on the topic.
Hey everyone, I'm Thomas. As Gien, I've been developer, now consultant, trainer, coach, and aggregates is still a fascinating topic, so that's why we're doing a talk on it.
All right.
Yeah, we're ready.
Yes, we are. So we work for a company called Aardling, and we're actually specialized in domain modeling and software design. And so to begin, I'm going to set a bit the stage. So often when we're designing software, people bother us with telling things that can and cannot happen. And one of the things that we always say is, we have invariants, and that's a property that must always stay true. For example, if you have a credit card, in Belgium, at least, there is a limit to how much credit you actually have. Say that it's 2,000. So keeping the invariant means that at no point in time is a credit card allowed to exceed that number. We're not allowed to have 2001. If we purchase something and we will exceed it, we actually decline that purchase. So we must keep invariants correct inside our systems. And the second thing is that sometimes we actually try to do things with multiple people at once, as is lovely when you're having software. And so we call that concurrency. We want to do something with multiple people at once. Imagine you have that same credit card, but it's sort of coupled to different accounts inside the family, and two people try to buy something at the same time. It means still we cannot go above that 2,000. So we actually have to decide what goes first and what does not go first. Should there be a decline? And we say that if we have that, so if we have a unit of consistency and concurrency, that is actually what an aggregate is. So if you have a car and you have all these entities and value objects underneath it, it does not necessarily make it an aggregate. When do you have an aggregate? Well, if you draw an explicit boundary around that, and if you have an invariant that you must keep consistent and you must take concurrency into account. That also means that the only way to change any of this logic is through the car. And that is an aggregate. Now, as I said, I've seen many systems, and we don't always do it that well, do we, aggregates? I think, personally, they were one of the hardest things for me to grasp from domain-driven design. So I'm going to introduce a few villains that I've noticed in the wild. So the first thing is the wrong aggregate. So we have constraints, things that can or cannot happen inside the system, but we don't understand them all that correctly. Or we implement them like a user must be unique when it is not true, so we implement them too strict, and that gives us the wrong aggregate inside our system. It's no fun to deal with. The second one is the enormous or the gigantic aggregates. I remember in 2014, when Twitter was still hip, your aggregate is so big jokes were flying all around because we just made them enormous. And that's not fun to deal with either, because if you have to refactor that, it takes a lot of time and a lot of effort. And so you're dealing with a constraint inside your code and inside your model that you actually just don't want to have there. And also, once you see an aggregate, it's very hard to unsee it. And so if you have an enormous aggregate, you just stop thinking about the alternatives. And then the last one is the unnecessary aggregate. As I said, it's about consistency and concurrency, which means that sometimes people draw a boundary and say, this is my aggregate, when you just do not have invariants inside your system. And that's important because we have a lot of patterns. We have tactical patterns, we have some strategic patterns as the bounded context, and it's important to actually use the right name. Your entities can be very complex, but it is still an entity. Yeah? You have a bounded context, and you may not have an aggregate, it's just a bounded context, and we need to use that right language for that.
Okay, so he introduced some reasons why we don't want an aggregate, what can go wrong. We don't want too big aggregates, we want to use them for the correct reasons. So let's see if we can find some hero aggregates in a domain that we're going to explore now. So the domain that we're going to explore is access control. We have a floor plan like that, and we want to both configure and enforce access control on it. And so let's explore this a little bit. I know it's not readable, but I'm going to go through it. So if you have a floor plan like that, that means we have a floor, we have different zones that you can see on it, and we want to configure the access to certain zones. How do we do that? Well, we have, maybe you can see it, we have badges that you scan at a badge reader, and the badge reader is linked to a portal, and either you have access and then the portal will open, or you don't have access and then the portal stays closed. Okay, so our language, the language that we use, are floors divided in zones where we have portals, badge readers, and you scan with the badge. One more thing is, of course, a portal needs to be linked and on a correct position. So we have a position as well where we configure portals and badge readers so that they're at the correct place. Okay, so two things we need to do. We first need to configure our access control, and the second thing is we're going to have to enforce it. In order to do that, we have 3 roles here today. The domain expert that I'm going to play most of the time, solution builder Gien, and storyteller, any of us, who is going to help us out if we're stuck.
All right, so I want my aggregate. Thomas, can you tell a bit about how the domain actually works? Okay. How do you configure access control?
Okay, sure. I think most of you are already a little bit familiar with event storming, but in the case you're not, a very quick recap here. Our blue stickies are actions that someone's doing. We're not doing the traditional event storming here. We're starting with actions. And our time flows from left to right. And so the first thing we're going to want to do is, well, let's add a floor. And, after we're adding a floor, we're probably going to want to add a zone, maybe multiple zones, I don't know yet. And if you then want to, if you want to access, you're going to have to add badge readers, and you're going to have to add portals, and then you're going to want to configure your access rules, and if everything's configured, you can publish it.
God, I have so many aggregates. Do I? Okay. So one of the first things we actually do as solution builders is that we often just immediately think, oh, and that's an aggregate, and that's an aggregate, and that's an aggregate.
Yeah, so that's something we don't want to do. We don't want to jump on any complex entity and think it's an aggregate. And that's one of the mistakes we often see. People hear a word, they think, oh, that's complex, it's probably going to be an aggregate. We don't want to start our design like that. Hey, let's first remember why we want aggregates, and that's we have some invariants and there is concurrency. So here, we don't know yet, but probably floors, zones, and badge readers are going to be entities. Again, we don't know yet, they might be aggregates. We don't have enough information yet.
Okay, so I need more information as the solution builder. So, Thomas, I noticed that you said you configure the access rules and then you publish it. But, and I'm looking for those invariants here, how do we know we're allowed to go from command to event?
So yeah, when you press publish, we need to validate that your access rules are configured correctly. So indeed, I see at the end, the result should be that the access rules are published. Actually, it says that the configuration should be, it's the full configuration that needs to be published. And yeah, what we do is we validate those access rules. For example, if you enter somewhere, you should be allowed, you should be able to leave as well.
Oh.
We rather not build traps where people get stuck on the inside all the time.
All right. So I have my second aggregate, which actually is a zone. Thomas has the clicker and he's way too fast.
Sorry.
I'm still looking at my solution here, Thomas. Yeah.
You're right.
So when you're allowed to enter, you should be able to leave, a zone. So a zone will be my aggregate. That's a very easy conclusion that you can do. But the thing is, zone, I don't understand that yet, and I made a mistake. Again, I didn't dig deep enough into all these constraints to understand what it is.
Yeah, we first need to understand it in better detail.
And I will use example mapping. It's called example mapping. We made some lovely examples for you. I'm going to walk through it to better understand what it actually means when people are allowed to enter, they need to be able to leave. So we have a zone, and I think at this point in time, that's my aggregate, so I modeled it around that. So we have two portals, and we have one badge scanner. Tell me, domain expert, is this a valid configuration?
Well, I think the room can see what's wrong with this. We don't have a badge reader at the exit, so no, this is not valid. You're not allowed to, you're not able to leave here. Invalid.
All right, let's make it a bit more difficult. I have one portal and two badge readers. One allows me to go in and one allows me to go out.
Yeah, clearly not valid either. You're still not allowed, just a different example.
Okay, so I can't check the badge readers. So I have two portals, and one allows you to go in, and one allows you to go out.
Yeah, I think that's the correct definition. We're allowed in, and we can exit again. So this seems like a valid example to me.
Yeah, excellent. I still think my zone.
Maybe it is.
Okay, let's make it a bit more complicated. Imagine that we have two zones, because you may not have noticed, but the domain expert did not really say what a zone is, but we know how buildings work. So as a solution builder, we often unconsciously make assumptions, and we have to try to break them. So I give an example, say we have two zones next to each other, and one allows you to go from the floor to the first zone, and one allows you to go from the first zone to the second zone. Is this valid?
Well, on the left side, you've configured the valid zone because you're allowed to enter and leave that one, but the right zone, you can only enter it and you can't leave it, so no, again, not a valid example.
So my zone here might not actually be the aggregate.
Oh, well, you could have two aggregates here, two different zones.
Yeah, but then, next example. We have, you can get into the first zone, and you can go in and out the second zone.
Well, here we're starting to see a problem, because according to our rules, we say, okay, if you're saying the zone is where you're configuring stuff, I agree, like, okay, you can enter and leave the left zone. You can also enter and leave the right zone, but you can never exit. So we've actually built a trap here. And let's agree on this. We don't want to build a trap. I don't think it's going to be very good for our product. Well, I guess we're not going to have a lot of customers in the long run if we
We're
build
actually
this.
going to have a lot of customers in that zone, though.
Well, and they have to wait for the new features to get deployed, I guess. Yeah. Yeah.
It's only 3 months and you'll be able to leave. All right, so zone clearly is not the aggregate here. And sometimes the reason why we do this is because we associate zone with room because it's what we understand. And we're always trying to understand the words that they are using. So zone just gets equated to a room, and you can leave a room and you can enter a room. But that is not what a zone is. So that is not where my aggregate lies. So I have to dig deeper. So imagine you have 2 zones, and you kind of create a walkthrough. You can go inside the first zone, through the second zone, out of the last.
That seems valid to me, yeah. So in this case, there are no rules that specify that you have to be able to go back to a previous zone. So here, this is valid. You can walk from one zone to the other, and then you can exit. It's fine.
All right, so my aggregate is something bigger than a zone, something smaller than a floor. But that is just one part of it.
Yeah, so currently we looked at configuring the access control. We didn't go in like a lot of detail yet. There are other constraints, of course, like if you have a badge, your badge is associated with certain roles, and certain roles have access in one zone but not in another. So it's a bit more complicated than what we've shown so far, but it's good enough to understand the main thing. So let's look at the second part, actually. So next to being able to configuring, we also want to put a product alive in production, and that means we're also going to have to be able to enforce these access rules. In a live system, when you scan, we need to be able to enforce them. And how is this going to look like? So we have Alice there in the bottom, and our examples are going to look something like this. The zone is the office. 2 badge readers for the same door. One goes in, one goes out. And so what happens is when Alice first goes to the office, she wants to read her badge. The badge is read. And then we, if the access control rules up until this part, the role is okay, then we will unlock the portal. So the portal unlocks. Alice will open the portal. She walks in, the portal will close behind her, and when the portal is closed, we're also going to lock the portal. So that's basically how the enforcement of the access control rules should work.
Okay, so we have configuration and we have enforcing. And there is clearly sort of a stop and a start here. We stop configuring and we start enforcing. And I can say, well, I will have 2 aggregates. One that does all of the configuration and one that does all of the enforcing. But as we said in the beginning, we're creating enormous aggregates. And language matters. So we do have configuration rules at both sides. But can you zoom out a bit?
Yeah, sorry.
Thank you. Domain experts are handy for other things as well. So we have them. But on one side, we use this word validate. And on the other side, we use this word enforce. And I can say, well, I just use an aggregate. But I also said that it's important to use the patterns that you have at your disposal. And one of the patterns that we have at our disposal is a bounded context. And just to iterate what a bounded context is, it's an explicit boundary that we design. So we choose what is in and what is out of this boundary. And what we want to do is we want to make a consistent model with a consistent language that actually solves the problem the best for us. So if I want to validate, I want to create a very specific model for that. And if I want to enforce, I want to create a very specific model for that. And so I'll actually get two bounded contexts here. One is sort of a draft. We call it a draft, a specification. It's sort of a pattern within bounded contexts, where everything sort of is, going a bit all over the place. And only at the very last point, when someone decides to actually publish, we take a snapshot of those access rules, and then we actually validate if it works. This also means that since I don't want to annoy the users, so I'm not going to use an aggregate, because if I validate every time, they're going to be annoyed. It's, yeah, I know it's not valid, but I still have to add all the other portals and all the other things, and why the hell are you annoying me? I could use, give a bit of warnings, but at the very end, I want to take a snapshot, and I'm going to publish that. And I'm going to create a boundary there, and inside that boundary, I will decide how to model it. And I might have very complex entities, but I will not have aggregates, because there is no real invariant there to actually enforce. And then I'll actually create some sort of summary event. I'll say, okay, these are the rules, and I will talk to my other bounded context that I created, which will be the enforcer, that will actually execute those rules. And so now I need to understand what it means to enforce rules, because I know what it means to validate. I know when I have to validate. We'll create a lovely interface where our front end and other services can talk to, and they don't even notice how I designed any of this. So an aggregate really is something within a bounded context. You don't really see how it happens. As long as you give back the right result, it's all fine. So we're going to dig a bit deeper into execution.
Yeah, we're going to do that, but first let's iterate the third mistake, and that is that we think we're always needing an aggregate. Like Gien just said, in the configuration part, we have other solutions to enforce the correct access rules, and that's by simply at the end of the process, hey, let's take a snapshot of the current configuration, use that, validate that snapshot, and publish it. So that's simple enough. We don't actually need an aggregate there. So that's something we also need to take into account. But as Gien said, on the execution side, things get a bit more complex. And so me as a domain expert, I'm now talking with Gien and saying, hey, so we want to build a system, and one of the things we want to have is high security zones. And a high security zone means that this is a zone where you can never be alone in the zone. So that means you always have to enter with two people at the same time, and you also have to exit with the two people at the same time. You can never have one person in that zone. That's not allowed.
All right. But as we saw from the first time, domain experts tell us things in the way they understand it, but that does not mean I fully understand it. So I love using example mapping. So I have a high security zone. I have two portals. You can go in, you can go out, and we have Alice, Bob, and Eve. And they're going to try to access this zone. And so it happens, Alice is tangoing at the door, trying to get inside, and scans the badge. And then Bob also scans the badge.
Yeah, that is a perfectly valid example. They both read the badge at the same badge. They are going to enter simultaneously. I'm just going to tell you one of the assumptions we're making here is, of course, that they're entering to the portal at the same time. We can just assume that we have the right hardware for that.
Okay. But Alice might try to do it alone. So Alice is at one of the portals and scans a badge. So then
yeah, here we'll need some kind of timeout. We will still need to figure out how much timeout exactly, but like clearly this is not the intent. Alice is not to be allowed inside. And if Bob arrives 5 minutes later and scans, we can't think, hey, now 2 people can enter at the same time. So we have a timeout that we need to make sure that we reset the state or something.
All right. So we have 2 portals, and Alice wants to access through the first portal, and Bob actually wants to access through the other portal, which means they actually are trying to get access at the same time. And as far as I understand right now, this is allowed, right?
Yeah, actually, let's not allow this, because this would be like accidentally that they be with 2 people in the same zone, but we want to make this really intentional. So that means we need to change the rule probably a bit, and I want 2 people to enter via the same portal.
Okay, so no accidental entrance
Yeah, indeed.
allowed. Okay, so now Alice and Bob are inside the security zone, and Alice wants to leave.
Same thing as on entering. If Alice only wants to leave on her own, that's not allowed. They have to leave both together.
Yeah, so even for exits, I will also need some sort of timeout. They have to happen close together. All right. So Alice wants to leave, and then Bob wants to leave via the same portal.
Yeah, completely valid. At the end, the zone will be empty.
All right, so 0 or 2.
0 or 2, yeah.
You already got that one.
Yeah.
Okay, so now this looks the same, but we had that accidental, and the domain expert said no. So I give an example to make it explicit. What happens when they're in the same room? They can see each other, and Bob has to go to the bathroom, so he wants to exit through the other portal, and Alice says, well, yeah, fine, but I actually have to go to floor B instead of A, and the elevators are close by on the other one.
That's a good one, actually. I haven't really thought that one through. Let's make an assumption here, and let's say currently we're going to enforce the same rules as on entering. You have to leave by the same portal. But I like, for entering, I have a clear reason why I want to do this. Here I don't really have it, but let's for now say they have to leave via the same portal, so it's not allowed.
Okay, well that makes my life a bit easier because I can treat in a bit the same as I can treat out. Okay, minimum 2 people. So we get how it works when we grow from 0 to 2, and we cannot go to 1. We get that. But when there are 2 people inside the room, right, we have Alice and Bob already inside that high security zone, and Eve tries to enter.
Seems completely fine to me. There are 2 people, so a third can enter as well.
Yeah, so it's 2 or more, but never 1. So that's something you don't always get, a 2 or not. So you could say, okay, but then if Eve wants to enter, we actually need Dylan as well, but that is not true here. And so Eve can happily go into the high security zone. But what happens when Bob wants to leave?
I think it's simple again. We still have 3 people, so 1 person can leave on its own. So Bob is definitely allowed to leave here.
All right, great.
Yeah.
Now I get this a bit better, and I understand the invariant, the rule, well enough to actually start thinking about design. I'm going to show you a technique that we use so that you can actually use your event storm as well when you're designing your aggregates. So the box, the big box in the background, or the boundaries of my aggregate. When I talk, I model in the same way. I make it explicit. This is my boundary. And I need to know if we have an action, what should happen. So my invariants actually go inside my box. And then decisions come out. And we have dependencies on those decisions. What I don't want is that I need to look outside of this boundary to actually get the necessary information. Because that means you will get inconsistency inside.
Yeah, so you're saying that if you're looking at information on the outside, that information could be changed by something else while we're making the decision. So that's something that we cannot allow. So this is a really easy model to validate, do I have all the information, if you can link all the information on your aggregate and you can see that they're all within the same boundary, it's really easy to see, okay, I have something that I can keep consistent. As soon as you have information from the outside, you're not actually sure anymore. Well, that information can change, and that means your invariant might break. So let's look at why, in this case, we need an aggregate. So let's assume we're in the situation where Alice and Bob are on the inside and Eve is on the outside. Alice scans her badge, and then Bob and Eve scan their badge at the same time. Those are the two blue actions on the edge of the aggregate. So we have read badge at C, and we have a second badge, the second badge because Alice already scanned, read the second badge at badge reader B. Our constraint says we are only allowed, there have to be two people inside the zone. So if we don't have a consistency boundary, we would risk that we allow both actions. We would say, okay, currently it's okay for Bob to leave, and currently it's also okay for Eve to enter. But if we're allowing both of these, we're breaking it because Bob and Alice are going to leave and Eve gets on the inside, one person in the room, we have a problem. So here we definitely need our consistency boundary. That means if we have the two concurrent actions happening at the same time, we're going to have to treat them one by one. And only one of them will be allowed to succeed, the other one will have to fail. So Gien, maybe you can take a look at how we can design our aggregate in such a way that we don't allow this.
All right. So we started when we were modeling. What we get from the domain expert was read badge, and we added Alice A to make it a bit clear, and we get a badge with reg. And then we have the second badge, and then we have the access rules. We try to enforce it, and then the portal unlocks. But that is actually hiding information. Because what we're actually saying here is that when we read a badge, we'll always allow that. And so when I'm designing to actually really understand how my aggregate functions, I actually even make those constraints like always and immediate, I make them explicit. So I added those two here for clarity. And then I look at my invariant. And I said, we don't want those dependencies outside of this explicit boundary that we drew. So what I will look at, okay, what information do I need here to actually be able to validate this? And I draw arrows. And at this point in time, it's actually when we have the fact that a badge was read. That is the information I need, and I make that dependency very explicit. And then we come up, if we sort of don't take a step back, what our design looks right now is we get a command read badge, always badge was read, but also we will validate and we have that dependency on the facts coming out of our aggregate. But that's not very handy because badge was read. We want to be explicit, language matters. So I'm going to introduce something that actually captures the fact that you just granted access to a portal. And so when we're validating the access rules, what I actually want to happen is that we get an access granted, that we can capture this inside our system, that we are aware of this, that it happens. And then the portal has to unlock. And that changes the design of my aggregate a bit, because now I have two possible events that can come out of my aggregate. We still have the always, but my access rule actually depends on the badge was granted, and it also depends whether or not an access was granted. Badge was read.
Badge was read.
Said the wrong words, but everyone is on board with this. And so my aggregate is already becoming a bit more complex. But the thing is that we had that whole, when there's a person at the door going in, and then we have people going out. And I want to know whether or not you go in or you go out. So I make it explicit. I make an explicit command here, okay, we're actually going out. And because we have that access granted and badge was read, I want to validate this every time. Because if we have 3 people in that room, 1 is allowed to leave. So I can't just wait for 2 badges and then validate my rule. I need to do it all the time.
Yeah, so just so that I understand, you're saying I'm going to remove the always here, and just at every step, at every possible step, you're going to try to enforce the access rules and see what happens. Okay.
And then we don't have the always, and then or invariants depend on badge was read and granted. And we have a distinction between are you going inside or are you going outside of my high security zone. So already looking quite different than what we started with.
Okay.
Anyway, so the problem was that if we have 2 people in the room and 1 already scanned to leave, and then Bob wanted to scan again, but Alice wanted to go in. So only one of those is allowed to succeed, which means that one of them will get an access denied, which is not fun to get, but we have to do it. So again, we want that to be explicit. We want to capture that explicit. So we'll have an access granted or an access denied coming out of our aggregate. So instead of just a simple badge was read, we already have 3 possible events and 2 commands going in, which we were not aware of, but this is how it looks like due to decisions that I made in the design along the way.
Okay, so currently we have this aggregate. I hope you all agree that it needs to be an aggregate because, well, we have a clear invariant. 0, 2 or more people, never 1 person in the room, and we have a possibility for concurrent access that we need to constrain. We need to make sure that it's an actual invariant, it's always true. So Gien refactored basically the design that we started with in order to design an actual aggregate, but she didn't change any of the rules. She just refactored some of the language where the rules are going to apply, but it's still the same rules. The refactoring happened in order to find a good aggregate. Now, I'm saying a good aggregate, but are we actually happy with this? Do we see any issues here? If we think back about reasons or problems with aggregates, well, clearly this one is necessary. We need something to enforce here. We need some consistency boundary in order to, so it's necessary. But for example, we also had, is it too big or not? Could we reduce the size of this aggregate?
Because we want a hero aggregate.
We want the exact aggregate we need. So one of the things I told you about, it was like in between slides, was when you read your badge, we also need to check your role. Now, are you actually allowed inside? But nothing of that is, there is nothing that says, oh, we need to check that inside the same aggregate. But currently, we're doing this. We read the badge, we validate the access control rules, and we say, okay, your badge was valid, and you have access or you don't have access yet. The validating of your badge is actually something we could move outside of the aggregate. We could say, well, let's move those rules outside of the aggregate, and we'll reduce the surface of our aggregate a little bit. So when we read it, something else, I didn't put a box around it, I don't know what, I don't care, we're just looking at the aggregate, something else will validate if you have correct roles or not. If your role is permitted, then we continue the process, and then we say to the aggregate, hey, someone wants to enter, can you please validate the high security access control rules?
Yeah.
Okay?
So one thing that we don't do is, so we started with the read badge, and you could say, okay, read badge, role was permitted, and then security zone read badge, but that's not what we are doing anymore, so we're changing language. So we talk about ubiquitous language, so we're also adapting how to talk about this, because we're trying to enter at this point in time. That's all that this is about, so we're actually going to use that language.
Yeah. So we reduced our aggregate in size. So we could say, well, probably we're happy right now. Maybe this is the ideal aggregate. This is what we want to put in production. But there is actually a problem with it. We can break our invariant here in a subtle way. Well, it's not so subtle once you're going to see it probably, but we can break it. At some point, Gien, I'll go back, Gien did this. She said, well, we're going to make this decision explicit. Let's make the decision access granted explicit, which I think is a great choice. Because unlock portal is probably some command that we have to send to hardware anyway. And if we put that all in the same boundary, we're going to have to deal with hardware-related things, and we probably don't want that kind of complexity. But it gives us a problem, because unlock portal is something that can fail now. Because, well, we send off a command to the portal, well, or we make a decision, access was granted, something picks that up and sends, or maybe the portal even listens to it and tries to unlock, but the portal unlocking can fail. And if the portal unlocking fails, well, no one is actually inside, and we think 2 people are inside. And then the next person that scans our security zone thinks 2 people are inside, so they're going to let them in. That portal will open, and 1 person is inside. So this is an issue. How can we solve it? Well, we can undo our previous change and put everything of unlocking of the portal back inside our aggregate. So we can grow our consistency boundary, make sure that unlocking of a portal is sending that command to the hardware and listening if it succeeds or not. Let's put it back in the aggregate. But now we're growing the size of our aggregate again. So what's an alternative? An alternative is we can introduce a feedback loop. And a feedback loop is when we have our access that was granted, where something picks up unlocking of a portal, and then we also have something that listens, did this portal unlocking succeed or not? And that, in turn, sends a command to the secure zone that it's confirmed or failed, and if we confirm it, we're going to update our person count, and we can now use that correct person count to make decisions. Yeah? What I'm not saying here is this design better than enlarging the aggregate? Because you could also, in that full feedback loop, you could put everything in the aggregate as well. That's a different design, but it's not necessarily a better one. But this is important, otherwise your invariants don't hold. So it's important that you actually model enough in order to make, to do that. Okay? Everyone happy with this aggregate right now? Okay. So let's have a look at our key takeaways. Remember, why do we need aggregates? We need aggregates in order to keep certain invariants when we're changing things and there is concurrency in play. That means if we want to build the aggregates, we first need to make sure that we really understand our constraints correctly. I would say that's probably one of the mistakes I most often see when I go consulting, is that people jump on aggregates when they don't really understand the constraints yet. Yeah? So that is first. That means if you don't have invariants, you don't really need an aggregate. Okay? And if you do have invariants and things, you have to make sure you model them correctly. As we just shown, it's not as trivial as thinking, oh yeah, we have a need. It can still go suddenly wrong if you don't actually own all the decisions. Unlocking of a portal, how many people actually went inside, that's the decision we need to know about. If we don't own that, and it's outside of our consistency boundary, it can still go wrong. So the main takeaway for us, I think, is when you're using aggregates and you're modeling, you want to make sure you understand the constraints well. You should design them thoroughly, so in order to do them. And if you then decide on something and you want to make something an aggregate, because of certain reasons, maybe you still want to enforce some invariants while the business doesn't need them. We're not saying that's wrong, but what we do say is make sure you understand when you're doing that, what the consequences are of that. Because sometimes it can be easier to say, hey, this thing, I'm going to put a transactional boundary around it. It makes it easier to reason about. But if the business doesn't really want that, or if the business doesn't enforce that, maybe in the future they will add some new rules, and that breaks your aggregate design, and then you might be in trouble. So it's okay to maybe add aggregates when you don't really need them, but only if you first understand the consequences of your design choices. Thank you.
All right, and we have our hero aggregates. Thank you.
I think we have time for a couple of questions, so if there are questions, we have someone with a box who wants to throw it, so there is a question over there. Yeah.
Where? How far?
You can do that.
There.
Hello, hello.
Hi.
Hi. Thank you very much for the quite interesting talk. I was wondering about the decisions I need to make on my way, and how to document them in an easy manner so that I don't need to write 40 pages of architectural decisions or something like that.
How to document the design choices that you make.
Exactly. As often I have a way left or right, as you described it quite well. But I need to, in my point of view, I need to document why I take the left way, for example.
Okay. So when we're talking about documenting specifically on the aggregate, I might add that in the code. Like we also talked about the bounded context and how we designed it. The first thing we did was actually say, oh, we'll actually separate this. And then I think that the architecture decision records are very well. So if you're making that on that high level, on that bounded context level, then and use that type of document to do that. If it's really about, hey, I want to explain why we designed this aggregate the way we is, because we're very much on code level, I would keep it close to the code.
Thank you very much.
Another question there? But
Yell into the box.
Into the box, yeah. So in the example with feedback loop, doesn't that introduce potential inconsistencies? Because now you could have a delay between the confirmation of the portal being unlocked or portal unlocked, like, or it's not delivered, something like that. And then you have an inconsistency again.
So we didn't go into too much detail here, but I don't think you, like, no, there is no inconsistency in the sense that, well, if you have, like between the portal unlocked and you confirm access, that is something where there could be a delay or something. As long as we don't have the confirm, we're assuming it hasn't worked. Okay, so inside our secure zone, we're assuming they're not inside yet. So we're failing here in the sense that there are people inside, and we're not going to allow other people in. So yeah, in some cases you could allow people in, or they could be in and we think they're not in yet. That's true. That's something we'll need to fix here probably. Yeah, you're right about that. We should. We can never break the rule, but we can get inconsistencies in the sense that there are people inside and we don't think they're inside yet.
So is it just the trade-off between larger aggregate with more consistency or more broken down with less consistency?
I think it's about that, but it's all like here, we didn't went too deep in this. This is actually like a real-world example, things like that happen. We have to communicate with hardware. And hardware, like they have different kind of, well, often we want to even make an abstraction of the hardware. So it could be not necessarily purely about the size, but also about what kind of complexity we allow inside our aggregate. But you're right, if we're doing these kinds of feedback loops, we're going to have to, like this is not enough. Like we should put things like timeouts, and if we have a timeout, we'll have to make a clear decision on what happens and what doesn't happen. If it's not about hardware and other things, I wouldn't mind in like, hey, let's grow the aggregate a little bit, because it's easier to keep things consistent in that way. Yeah?
Thanks. Where to?
Any other question? There was another question, yeah.
I think we have time for one more.
Thank you very much for a very interesting session. I was wondering I know it's not the subject, an eye on event sourcing. Do you consider the volume of events that will go through the aggregate during its life cycle, during the design, and if so, when?
So if I understand your answer correctly, like, do we look at how much the aggregate will have to deal with?
Yes, over its like full life cycle. Like this, if you have a really big room and this lasts for a while, this could be many events.
Yeah, we didn't touch on that, but we do look into it. So what you want to avoid is a never-ending aggregate. That also depends, like if you have an invariant and one command goes in and one event goes out, and it also depends on the technology that we use. If we use event store, for example, it can deal with quite a lot of events. It can actually deal with a lot more events than that we make the assumption that it can. So that's fine. But at some point, creating your state will just really get cumbersome. And then we like to use a technique that is called close the book. And it's it comes from accounting. where if you create your company at the 5th of February, then the next year, the 5th of February, they say, oh, well, your counting is now, your book year is finished and we go into a new book year. Okay? And so we have techniques similar as the close the books to do the same for your aggregate. But you also design that, so you will deliberately introduce commands and events that will say, we close the books, and then you will get a command with the last state of that aggregate, and then you will say, open book year with the better name, and then you will put that and you'll have your correct state. So there are definitely ways to deal with that, and we also always look at how do we expect this to grow and how, but we won't do that immediately. Once you start finding, because that adds a lot of complexity, so once you start finding those issues, you refactor them to make sure that you can deal with that and you get something like that into production.
Here it's actually, in this example, it's actually a really easy one. Like every time your zone hits 0, you end your aggregate and you start a new one. So, well, unless you have zones that grow, but here it would be a really easy thing to do. Yeah. Okay, I think we're out of time, and I think you're all hungry and waiting for lunch. So thank you again for joining.